This video is about finding the slope of the least squares regression line equation when the explanatory and response variables are interchanged. Once again, I'm using the distance and ticket price worksheet example that we have been discussing in class. Looking at this once more, we see that the original equation where we predicted fare from distance, we were able to show that at this point it says fare hat equals 177.215 plus 0.079 times distance, and includes the very long many decimal places version of R, which we already did earlier. But now we've been predicting airfare based on distance. What if we wanted to predict the distance we could travel based on how much money we have available for airfare? That is, we want to know the slope of an equation in a form where we are looking at distance hat equals some y-intercept b sub 0 plus the slope, that's what we're really going to go for, b1, the slope, times the fare, the amount of money that we have in our pocket. I'm going to write, I have already written some of this out, so I'm going to remove this paper for now and show you some of the things that I already wrote as notes, and we'll actually look at them kind of step by step, so cover up some of it as we go and uncover it as we go. So here's what we already know. We know that R squared was equal to 48.2%, and from that was given in the computer output, so that needs to be shown as a decimal. R squared equals 0.482, and then in our calculator we can take the square root of 0.482, and we get rounded that R, the correlation, is 0.694, which we've already said is a moderate association between airfare and distance. Our b sub 1 for the for fare predicted by distance is and using all the decimal places from the computer printout, 0.078619. That was in the computer printout. Once again, show you that. It was right here. Okay, we had the y-intercept and we had the slope. Okay. We also know that we have a formula that says we can find the slope if we know the correlation and the standard deviation of y divided by standard deviation of x, where this is the response variable and this is the explanatory variable. So what do we already know? We know that our b sub 1, if we round it, is 0.079, rounded from here. And we know that our slope, we've already rounded that, is, sorry, not our slope, our correlation is 0.694. We don't really have to know the standard deviation of y and the standard deviation of x. As you will see, we don't have to know those in order to find what we're actually looking for. What we need is this value, the division value, but not the individual values of sy and sx. So to solve for sy over sx, just that single value, we divide both sides by r, the correlation. So here's what the division looks like. 0.079 divided by 0.694 is going to give us standard deviation of y over standard deviation of x. And when we do that, this is what we get. we get a very long decimal value, 0.113832853, but that actually equals sy over sx. Now, how in the world are we going to use that to find the slope of the new least squares regression line equation when we want to reverse or interchange the x, sx, and sy? We want to interchange the y's and the x's. What we're looking for is sx over sy. If we were interchanging them, sx would now be the response variable, and sy would be the explanatory variable. So that is the reciprocal of what we already have here. Sx over sy is the reciprocal of sy over sx. So if we want to turn this one upside down, then we have to find the reciprocal of the side where we have a value. So we can write this reciprocal is 1 over 0.113832853 equals sy over sx. Now, I've already gone past some of this in my calculator, but I'm going to show you some of this again. All right, so in the calculator, if I do that bit of division that I showed here with 0.079, the slope divided by correlation 0.694, that's where I get that very long value. Now I want the reciprocal of that. I do not have to round it. I do not have to do the long division. All I have to say is 1, that's the new numerator, divided by this answer. And in our calculator, we have a place right above the negative sign at the bottom of the calculator. I have to move my calculator enough so you can see it. We have ANS in whatever color your shift key uses. So if I click on second and this negative sign, I'll get second answer. And so when we look at my screen, that's what we have. Second divided, 1 divided by answer. If we press enter for that, we get the result of 1 divided by this value that we had gotten in the previous part of the problem, and therefore what we have, let's see if I can show both things at once, is 8.784810127, that's this value, that equals the standard deviation of x over standard deviation of y. Okay, we're almost there. Our formula would say our slope, b sub 1, would equal r times the standard deviation of x over standard deviation of y. Well, this is the standard deviation of x over standard deviation of y, and we still know r. R is 0.694. So all we have to do is multiply 0.694 times this, and we'll actually have the slope that we're looking for. And that's what we do here. So if I take this value, and again, I can use my second answer part of this, I can say 0.694, the correlation, times second answer, the most recent answer, and I get 6.096658228, which is the next line that I've written on this paper. We're really almost there at this point, because I'm going to round that to this is the slope, r times sx over sy is the slope, b1, and I'm going to round it to 1 decimal place, 6.1. I rounded to 1 decimal place because if we look back again at that paper that we were working on, the worksheet, when we look at the computer printout for distance predicted from airfare, we see that the slope on this paper is 6.13101. So if we rounded to 1 decimal place, we would be at the same spot, 6.1, for our new equation would be our slope. Okay? So that's all you have to do. If you know the correlation, or if you know r squared, so you can get the correlation, and if you know the slope of the original version, you can get the slope of the reversed variables, the interchanged variables, just following these steps. And